All right. Well, happy New Year. Happy whatever this is, January 10th here on the East Coast. I am Whitney, or Whit. I am in North Carolina. I'm in Durham, North Carolina, actually. Go Duke. I've been teaching with Manhattan Prep since 2010. So a really long time at this point. And I'm just in love with our free prep hours. The fact that this is something that we even do makes me so happy. That after all of these years, to get a chance to teach kind of the fun little one-off topics that, maybe we don't always get to teach because the class is so busy, or that I only get to teach to my tutoring students, to get to give them to everybody is pretty cool. I had a request for this one, and the request went like this. I have done so much foundational work on percents, and then, by extension, fractions and decimals. And I've seen the free prep hour on the foundations. But I'd really like to see more percentages, and then again, fractions, decimals, in word problems. Because it seems like once there's a story around them, it's like the mechanics kind of disappear. So can we do some of those tonight? And I was like, absolutely. Absolutely. Yes, Liv, absolutely. And so what I want to talk about tonight is just that: fractions, decimals, percents, word problems, because they really are all the kind of same family. And this idea that often memorizing a bunch of percentage rules can at times hurt us a little bit on these word problems. And it's because often when we see word problems on the test, there's this immediate need to put things into formulas, into equations. We've got that trusty calculator, right? So we want to go nuts. And I know that it's easy for me, and I'm going to assume for you guys too, to forget that these are stories about a real world. The beauty of a word problem, the beauty of a story problem, is that it's a real world thing. So the reason why I bring that up is because the most important thing you can possibly do for any word problem, regardless of what topic is underlying it, be it a word like an algebraic problem, or if it's rates, or if it's geometry, or if it's percents, your first job is to make sure you understand the story. Like, visualize it as if you were standing in the world with that story happening. So we're going to do just that. We're going to start with a pretty simple example, and then we'll kind of build up as we go. And we'll see a few pretty common techniques that work against a lot of fraction and percent problems. But I want you to take a moment with this problem, not to think about the math, but I want you to take a moment with this problem to literally sit down at the table with Manuel. I want you to see what's happening. Now, granted, this is one of the GRE's more obnoxious question types, which is a fill in the blank. So we can't use estimation, but we still can think about the story so that we avoid picking or coming up with numbers that would be way out there. So let's just take a little bit. Do me a favor, type in the chat window what you think the answer is. We'll take about a minute. All right, so I'm getting a bunch of similar answers. Mm-hmm. Let me ask you this. If I have 2 bowls of soup, so if I have 2 bowls of soup, and I eat a quarter of one of those bowls, and 2/5, which is approximately what? What's 2/5 going to be? like around. What fraction is it close to? It's like almost a half. And Renee, like, I love that. It's like almost a half. It's not quite a half. So this one will be like a little bit less than a half. So just pause for a second. If you and I were sitting at a table and you and I each have 2 bowls of soup, and I eat a quarter of the first bowl and then give you the rest of it, and then I eat a little less than half of your bowl and give you the rest of it, which of us is going to be eating more soup? You or me? Who's having more soup? Me eating the 1/4 of a bowl and 2/5 of a bowl, or you eating the remaining 3/4 of a bowl and 3/5 of a bowl? So me or you? Who's the one eating more soup? Yeah, the second person, right? Because if we look at what I'm eating, I'm only getting these little blue chunks. Whoever the other person is, it's getting these bowls, is getting this part. So if we look at a single pot of soup, I'm not getting half of the soup. In order to get half of the soup, I would have had to have eaten a whole bowl. And I don't get a whole bowl. I get a quarter of one bowl and like not even a half of the second bowl. So I'm not even eating an entire bowl of soup. The other person is getting more than a half of that soup. And so I got a ton, and I mean the vast majority of answers came in as 13/20. But what do we know about Manuel? Is he eating half of the bowl of soup or half of the pot of soup? No, right? Manuel's down here eating these slim bits of blue. He's not eating half the pot of soup, which means 13/20. That's over half. That's almost 3/4 of a pot of soup. How do we get to 13/20? Where does that answer come from? So where did we get that? Common denominators, and said, okay, well, Manuel ate a 1/4 and 2/5. So this would be 5/20 of one bowl of soup. This would be whatever that would be, 8/20 of a bowl of soup. And so together, what is 13/20 then? What is 13/20? 13/20 of what? So he's eating 13/20 of what? Of one bowl of soup, right? Because we want to think about what we're taking these fractions of. So 15/20 of a bowl, and he gets another 8/20 of a bowl. So he's eating 13/20 of a bowl, but there are 2 bowls. So in essence, I'm going to have to see this as 13/40. Ooh. So here's what happens when we jump in to fractions and percents. Yeah, and so Tanya, we're going to take a look at it. We're going to take a look at it. And what we're going to do is we're going to put some real numbers in this to help it make a little bit more sense. Okay. What I want to be very careful of in the world of percents and fractions and decimals is that I've got to think about what I'm taking a percent of, what I'm taking a fraction or a proportion of. Right? I have an entire pot of soup broken into 2 pieces. Let's imagine for a moment that the entire pot of soup is, let's call it like 20 cups. This is a big bowl of soup. Big bowl of soup. And so, or actually, I'll come up with something maybe even like, we'll use these like little 20 cups. Whatever. So if we've got, and this is gonna be a little bit messy here, but if I've got 10 cups over here, and I've got 10 cups of soup over here, well, how much is Manuel eating of the first? I guess I should say like 10, maybe I'll call this 10 ounces instead of cups so I don't confuse it with the word cups. So what if Manuel eats a quarter of those 10 ounces? How many ounces of soup does Manuel have from the first bowl? Yeah, 2.5 ounces. The number's not the prettiest in the world, but we'll live. Okay. And now in the second bowl, Manuel is having 2/5 of this bowl. Yeah. So Manuel is having 4 ounces. So Manuel is having what, 6.5 ounces of soup out of a total 20 ounces of soup. And so this is clearly less than half, clearly less than half. Now, I had a couple of folks go like, well, wait a minute, wait. Notice what happened when you found the common denominator. I'm going to switch these numbers up a little bit. Finding the common denominator was like saying, ooh, let me make these numbers really pretty. I'm going to make each bowl 20 ounces. Right? Each bowl is going to be 20 ounces. And the reason why that's so lovely, right? The reason why it's so lovely is because 20 ounces, well, I can take a quarter of 20 ounces pretty easily. So that's going to be 5 ounces. And I'm going to take 2/5. That's pretty easy. That's going to be 8 ounces. If we calculate the answer as 13 ounces over just 20, then we are calculating what fraction of a bowl of soup did Manuel finally get to eat. But I want to know what fraction of all of the soup. So I need that bigger denominator. And so I'm going to need this to be out of the total possible ounces, which is 40. But notice what often makes these problems make sense is to fully make them real. And I know I do this in a ton of free prep hours. And so you'll probably see this in places, this idea of like plugging in your own numbers, making it real, or just drawing pictures. Like I'm a huge fan of drawing pictures because I feel so much smarter when I have a picture in front of me. Yeah. And so at a minimum, I could say to myself, okay, wait, 13 over 20 can't be right because Manuel doesn't even get a whole bowl of soup. Like poor Manuel isn't even getting one. You know, poor Manuel's getting like some small portion of the bowl of soup. Yeah, and I do. This is a strategy that you can use right away. Now, this one's a little tricky because it is fill in the blank, but a common technique for something like this is when like the concrete values don't exist. Everything is sort of a relative value. That I have like 2 bowls of soup, but they don't really tell me what's in them, how much is in them. And then they do give me just these like proportions. And so that's a good way to go about it. And yeah, Maya, you can put in, it doesn't have to be a reduced fraction. It does not have to be a reduced fraction. So any variation of the fraction, 13 over 40 works. Yeah, and the 20 ounces often when dealing with things like fractions, I'll do exactly what several people in the window messaged, which was find a common denominator. So when I'm trying to come up with a number to pick in a fraction word problem, I'm going to pick a common denominator. If I'm trying to come up with a number to make a percents problem real, what do you think kinds of numbers would I think about if I were in a percents problem? And I thought, maybe if I made this real, that would be really helpful. What sorts of numbers? Yeah, numbers like 100 or 1,000, things that are easy to take a percent of. Yep. So a lot of times, fraction, decimal, and percent problems are possible. Like it's easier to deal with them if you just make them real. Now, we can't always do that. We can't always just make things real. Sure. Well, actually, I want to see if anybody who would be willing. Right. Well, actually, maybe, Brittany, you can help me here. You can help me here. So in this first bowl, right, each one of these boxes is a bowl. In this first bowl, Manuel ate a quarter of the ounces. So if Manuel is eating 1/4 of the 20 ounces available, how much would Manuel be eating? And this little blue represents the 2/5 of this bowl of soup. So what do you think, Brittany? How would I get from 20 ounces knowing that Manuel ate a quarter of it? Okay. So we have a great free prep hour on sort of like the basic mechanics around fractions. But if I want to know, part over whole is just a set of ratios, part over whole, part over whole. And so I know that I want the fraction. And so you could look at one side of this part over whole equation as the fraction, like the raw fraction itself. So 1/4 is equal to some unknown over some total. In other words, I'm taking 1/4 of the 20 ounces I have available. So 1/4 of 20 is 5 ounces. And then 2/5 of 20 would be 8 ounces. Cool. All right. So let's look at another one that's kind of on the like more upfront kind of way, like short. It's not super dense and wordy. We'll try another. And again, we'll take about a minute and let me know what you think the answer is. And we'll take just another like 15 seconds or so. My favorite. I'm getting a lot of like, oh my gosh, help. Oh my gosh, this is such a mess. How do I do this? Help. Help. Help me. So what was such a nightmare about this problem? What do you think? So much stuff. So much stuff. They didn't give me a total amount. In fact, that's what they were looking for, right? They're like, if they had just told me from the beginning how many, they were like, I don't know, 350 monsters. Off I go. Then I have to find a common denominator of 3 really ugly fractions. What is the common denominator of 2/5, 1/7, and 1/3? 2/5, 1/7, 1/3. Yeah, the common denominator is 105, which is not super lovely. Ah, okay. So be careful. We don't have to multiply them all together. We don't have to multiply them all together. But in this case, we do, but we don't have to like start squaring and doing all kinds of big things. Yeah. So the common denominator here would be 105. And it would in fact be 105. But I don't know. That's not the most fun, personally. I mean, we do it. Let's do it. Let's do it. Okay. So the common denominator is 105. So I'm going to come up with 3 fractions. I'm probably going to add them together because these are some of my, horned monsters. So this one's a little less than a half. So it's probably going to be like 50. 7 times 3 is 21. Times 2 is 42. That's how I do my common denominator. This one's already got the 5 down here. I just need the 7 times the 3. This 105, I already have the 7. I just need the 5 times 3. So there's my 15. This 105 already has a 3. I just need the 5 times 7. That's the 35. So I'm going to put it up here. Okay. Then I got 35 plus 15 is 50 plus 42 is 92. So 92 over 105 is the sum of these 3 fractions. What does that even mean? What is 92 over 105? It's definitely over half. It's almost a whole. But what does that mean in terms of the story? Like it's great. It's a fraction, but like, what does it even mean? Yeah. Okay. So 92, if there were 105 monsters is really what this is saying. If there are 105 monsters, 92 of them would have fewer than 3 horns. So 2 horns, 1 horn, or no horn, which means the remaining 8 plus 5. So 13, those remaining 13 out of 105. So the difference, those 13 out of 105 have 26. But now I'm having to think like, okay, 13 out of 105. If I wanted to figure out what 26 was out of, I could, 13 doubles up to 26. So 105 doubles to 210. So technically, if I had 210, yeah, great question. If I had 210 total monsters, then 26 of them would be the 3 or more horns, which works out. Yeah, so this 13 comes from the fact that if 92 out of my 105, then what about the remainders, right? So if I've got 92 out of 105, they're one certain thing. The other 13 have to be something else. Yeah, no worries. Well, and so the only reason why I doubled them is because this number said 13 and that number said 26, so I doubled them. But let me back all of this up for a second. There is, oh my gosh, I'm so glad you asked, Rebecca. There is such an easier way and a way that's more intuitive. Why is the thing I'm doing on the screen right now potentially not intuitive? Because it's just a bunch of random numbers that are meaningless. It's just a bunch of random numbers that are meaningless. And somebody said, now I want to make sure, I want to scroll back up and try and credit this to somebody. Patrick said, you know what stinks about this? There's no real numbers. There is an equation, Emily, but it's sort of weird. It'd be like, if I were to say 2/5 of the total number of monsters plus 1/7 of the total number of monsters plus 1/3 of the total of the monsters plus the 26, right? These monsters, that would be all of the monsters. And now I have to solve that. I have to find my common denominators and solve it, which is really what happens with this whole mess up here. I'd say this, either of them are really ugly. But I'm going to first piggyback on what Patrick said, which is they didn't tell me the total. Because man, wouldn't that have been easy if they just given me the total from the beginning. They just been like, here you go. There's how many. Well, they didn't give me the total. So there's a part of me that kind of wants to make one up. The problem is that like in that last problem where we just like made one up, we can't just like make one up for this because there's a real number that got thrown at me, that 26. And so, Patrick, beautiful idea. We can plug in answers since the thing that I want is the total, right? The thing that I want is the total. That's the answer. But I'd also like the total because that would have made this problem easier. Then I'm going to marry those two pieces together. I want the total because it would make my life easier, the question wants the total because that's the answer. So I could go through, right, work backwards, and I could test out every single one of these answer choices, which sounds like, Whitney, are you messing with me right now? I have to take like 2/5 of it and 1/7 of it and 1/3 of each of these answer choices. Like, I know I have a calculator, but really. But Annalise threw something lovely in the window. Unfortunately, not to everybody, just to panelists, but Annalise, I'm going to credit you with this. Couldn't I just sort of tell that 210 is the only one that's divisible by 7? Yeah, you totally could. You totally could. Right? So if what I know, and I should probably assume that I'm going to have whole numbered monsters, right? If what I know is that I have to be able to have some number of monsters, 2/5 of which have no horns, then I need an answer that I'd be able to take 2/5 of. Well, that doesn't help me much because I can take 2/5 of every single one of these answers. Anything that ends in a 0 is going to be divisible by 5. So that's not the most helpful thing in the world. But if I would need to take 1/7 of something, well, 100 is not divisible by 7, not by like in a whole integer, and 130 isn't. 140 would be, but it's not there. And 180 is not, but 210 is, and 260, well, I'm done now. That's the only answer that I can take 1/7 of. It's the only one. Nice, Sydney. Excellent. Right, it's the only one. Testing out the answer choices. The good news here is there's literally only one answer choice that'll do it. In fact, if I wanted to find answer choices that were divisible by 1/3, there's only 2 of those. 180 and 210 were the only 2 of those, and I could have tested just those 2. That would be the quick solution. This is the quick solution. I'm done. The answer is D, because it's the only one that I could take 1/7 of. Otherwise, I'm doing a bunch of algebra. So what I want to so question in the window, like how did I do this? I literally said, well, which of these numbers can I take 2/5 of? And it's like, well, I could take 2/5 of all of these, and I could plug in my calculator. 2/5 is the same as 0.4. So I can multiply all these things by 0.4 and see that like whole numbers spit out. But if I try to take 1/7 of these numbers, what I'm looking for is a number that's divisible by 7. In order to take 1/7 of something, the number has to be divisible by 7. Like I can take 1/7 of 7 or a 14 or 21 or 28, right? 35, but I can't take 1/7 of 100. Yeah. So here's what I would look at, Patrick, is like a couple of pieces. It's not like, oh, I see a fraction, I immediately test answer choices. Right? So we have to take a step back for a minute. What I want to start to do is remember that these are just stories, that these are real things happening in, I mean, granted, they're monsters, but in like a real world. And so if I just start throwing fractions at things, is that what you're going to do if you're standing in the real world trying to figure something out? No. Most of us standing out in the real world trying to figure out how far something is away or how much money I need to like give somebody, right? I'm not going to sit there and start running through like really big complicated equations. I'm going to like, I don't know, like I owe you about this much, or it's about that far, or like, oh, there's this much between the two. I'm going to just start thinking about it logically. I want to do the same thing here. It's like, all right, well, if 2/5 of the monsters have horns or have no horns, then I can like start to look at my answer choices. Well, 2/5 is, I mean, I can start from the beginning, but what I might notice is if I'm already going to start picking at answer choices, what if I move to the fraction that's the ugliest? Let's start there. And with a little bit of knowledge of the fact that the GRE is going to give you gimme answer choices. They're going to give you answer choices that you can eliminate. So it's like, oh, well, I also know that 1/7 of whatever number of monsters there are have 1 horn. So which of these answer choices can I take 1/7 of? This one is extra special easy if I catch that, because there's only one answer choice that I can take 1/7 of. Only one. Now, let's imagine there was more than one, right? Just to kind of appease. Right? Let's say I got down and it was 210 and 350. I was like, well, it could be either of these. Now what? What would I do if there were 2 answer choices that were both divisible by 5, 7, and 3? And actually, hold on. I need to come up with a different one. That one's not right. I need it to be, let's go 420 instead of 350. We have to jump all the way up 420. Yeah, thanks. 420. But yeah, and I could do that. I could have just tested and been like, oh, it's not divisible by 3, so I couldn't use that one. But let's say there's 2 answer choices that both have. Yeah, I just try them. So I'll go, okay, let me take 2/5 of each of these. So if I were to take 2/5, right? So I take 2, like to take 2/5 of 210, 2/5 of 210, I would take, 420 over 5, throw that in your calculator, since these numbers are kind of ugly. This would be 84. So 84, if there were 210 total monsters, 84 don't have horns. A 7th, which in this case is a little easier to calculate, is 30, have 1 horn. And a 3rd, which is 70, have 2 horns. So far I've got, throw it again in your calculator, 84 plus 100, so 184. And so does that leave me my 26 left to get there? Right? This total is 184. If I then added the 26 remaining, right, these are my 3 plus horns, I do in fact get 210 monsters. If I had started with this bigger one, or I'd started with one that was wrong, this one would have been 168. This one would have been 60. I'm just, you'd run them into your calculator. This would be 140. This would be, 184 times 2. 368. If I took 368 and added those 26 remaining 3 plus, oh, that's not going to equal my original 420 that I started with. So that can't be the right answer. It doesn't work out. It doesn't work out. And so the idea is that it could be really nice just to think like, well, what is it that they're looking for? Oh, I'm supposed to like pull this piece. So before you jump into a problem, we're gonna try another one. Before you jump into a problem and start like trying to build a bunch of equations and write variables and find all your common denominators and such so forth, take a minute and sort of ask yourself, could I sit in the real world a little bit? If I can't sit in the real world, could I put my own numbers in it so that I could sit in the real world? Because percents and fractions are things we deal with all the time. Right? We work with these things literally all the time. So let's try another one. Can you just like make it real for yourself? All right, so I'm getting a bunch of different answers. I've got votes for 20, 21, and 9, as well as some like, I don't know. I don't even know. How would I do this? So sit down. right? Sit down with OECS, sit down with and say like, hey, all right, let's look at your budget for a minute. Let's look at your budget for a minute. And I like a picture. Okay, so if this is 100% of my budget, half of it gets spent on rent, utilities, and insurance. Another 20% of it, this is 50%. Another 20% gets spent on food, which leaves what percent of our friends' income is left? Yeah. So this part right here is 30%. It's 30%. Okay. So if I only spent money on rent, utilities, insurance, and food, I'd have 30% of my income left. Right. So here's what I said right now. I have 30% of my income. So I'm not gonna like mark it up. This is what is, I'll block out what's been spent. So this part spent, this part spent. So I have 30% left right now, but I'm going to spend some of that. So what answer choices go? I didn't spend this 30% yet. Not yet. We haven't gotten to the next piece yet. Up to this point, right? A goes. Yep. Because he's not going to have 30% left because I'm going to spend at least some of this. What percentage? Like what happens next? What happens next? Yes. So Amanda points out he doesn't spend 30% on video games. He spends 30% of what's left on video games. So he's going to spend about a third, right? Because 30% is not a third. A third is what percent? What percent is a third? Yeah, a third is 33%. So he's not going to spend a third, but approximately, right? In my mind, if I'm just kind of thinking, it's like, well, if he spends a third of this 30%, he's going to spend like about 10 more percent. Like about 10% gets spent, which would leave about 20% unspent. About. Which means D and E both go as well. Because I'm going to have about 2/3 of that 30% left. So how do I decide between B and C? Because they're awfully close. I guess technically I have to solve. I have to take 30% of 30%. Or do I? Or do I? What is 30% of 30%? Where would that come from? Ah, right. But he's not, it would leave 20% if he had spent a third. Right. And so this is another place where you're like, oh my gosh, these percents are making my head hurt. Make them real money. There's no real dollars. So let's say he has $100. Right. Let's say he's got $100 to start with. First he spends, and we're just going to subtract off what he spends. So first he spends $50 on rent, utilities, and income. And then he spends $20 on food. And then it says 30% of the remainder. So let's take this little subtracting thing first. We start at 100, take that off, take that off. Okay, so he's got $30 as the remainder, and he's going to take 30% of it. So 30% or 3/10 of 30 would mean he's going to spend $9 on video games, which means he's left with $21. I could also look up here and say, all right, if this block is 30%, I've got a 10% block, a 10% block, a 10% block. So he's spending a third of that remaining 30%. He's not quite, but he's like almost spending a third of that, which means he's almost spending 10%, leaving almost 20%. But those numbers aren't exactly right because I did those numbers using 33%, which wasn't true. And so I could, if you start getting comfortable with percents as well, eliminate C because I know it's not going to be precise. We don't cross multiply. You mean like 30 over 100 times 30? Or in other words, 30 over 1? Yep. And so I don't ever multiply first, divide first. So one of these zeros would cancel with that one. One of these zeros would cancel with that one. And so you get 9. So you don't cross multiply. You multiply across when you're multiplying. So if I wanted to multiply like 1/2 times 3/4, I multiply across. This would be 3 over 8. I just canceled first. And again, if you're like, I don't really remember how to cancel, I'm not really feeling so good about my percents, we do have an amazing free prep hour that talks about like the fundamentals of fractions, decimals, and percents. Right? So like getting down the mechanics before you start digging into the stories. But I do find with some of these stories, rather than getting kind of hooked on the algebra, it can be nice to at least use some of the logic in the background. Here we go. Let's try another one. Give yourself a chance to make it real. All right, so I've got a bunch of people guessing A. I had quite a few pick A, so we're going to start with that one for a moment. Let's imagine it is A. Right, let's just imagine. If it is A, so if her salary is $160, what would I do to test this out? How much does she spend on rent? Rent would be 5/8 of 160. And 8 goes into 160 20 times. So rent would be $100. How much would she spend on food? How much would she spend on food? So here's what I need, right? Food is a third of the remainder. So the remainder, this leaves $60 at the moment. Food is a third of that, which makes food $20 because it's a third of the 60. 1/3 of that 60. So she spent $120, which leaves $40. And that works. And that works. Notice that this was similar to the one we saw before, right? 5/8, and then we saw the 1/3, and we saw a real number. I was like, oh, we should test the answer choices. But you know what? We didn't want to just take a third of the answer choices. Why not? Why didn't we? Because if we had said, well, 160 is not divisible by 3, so let's eliminate that one. Why not? Why don't we divide the answer choices by 3? Nice, Rebecca. It wasn't that she spent a third of the total on food. It's that she spent a third of the remainder. So again, I think sometimes even if you're going to start to set up, math or what have you, I like to think of it as sometimes breaking these things into little segments. So 5/8. All right, well, I'm going to break this up into 8 slices just because sometimes that makes my life easier to actually see it this way. So let's say her income is 8 slices of something. She spends 5/8. So 1, 2, 3, 4, 5/8 on rent. And then it says that she spends a third of what's left. Well, now given my picture, I know exactly what she spends, right? 1/3 of these final 3 pieces, she spends this. And now these 2 pieces at the end, those are what equal $40. What sort of sneaky thing could I use at this point, given that those are $40? How could I extrapolate what the total value was then, if the pair of those together are equal to $40? There's a couple ways to do it. How do I get from knowing that? I can do a part of a whole. Yeah, so I could say that this is 2/8. So 2/8 of some total is equal to $40, and I could solve. Or I could recognize that if 2 chunks, and these are all the same size chunks, if 2 chunks are equal to 40, well, there's 2 more chunks, and here's 2 more chunks, and here's 2 more chunks. Well, that's $160. Anytime I can draw something with a picture, sketch it out, I can think about putting in a number, I can use the answer choices. When I'm dealing with things like fractions and percents, this is a big deal. You have no idea how much you use fractions. You do not give yourself credit for how frequently you use fractions and percents. This is probably the one area that people screw up the most, but technically need the least prep for, because these are concepts that you bump up against all the time, literally all the time, all the time. What about this one? We'll try another one. Similar kind of vein. Nice. I like it. I like it. What's a first move we could take here? And before you ask, oh gosh, is this a super easy question? The answer is no, because most people try to sit down and come up with a bunch of variables. What could I do? Yeah, I could say okay, in a parking lot, a third of the vehicles are black. Okay, well, then there can't be 8 cars in the lot or vehicles in the lot, and there can't be 20 or 35 because I can't take a third of those numbers. Well, then don't forget though that this is a fifth of the remainder. So I'm not checking my answer choices for divisibility by 5. I'm checking to see if the remainder is divisible by 5. So if a third are black, if a third are black, then that means 4. Or in this case, it'd be 10, which then the remainder would be 8. The remainder here would be 20. Well, of these two, I can only take a fifth of this one. So it's not that 30 is divisible by 5 necessarily. It's that the remainder is divisible by 5. So we're going to set it up and make sure that we're like, okay, look, let me just check. A third of all the vehicles. And so be careful when we're looking. It's like a third of the vehicles, a fifth of the remainder. So I always have to be very careful. What am I taking my fraction or my percent of? What am I taking them of? Yeah. All right, let's try one more. Let's try one more. Yay, another little bit of a stumper. So I think the rule of thumb, and I had someone mention in the chat window, like, I get this, I understand them. I just definitely am going to need to be practicing more so that I can be quick enough, right? Like not wasting time. One of the things I want you to constantly think about, if it's a story problem, your first job is like, do I even understand what's happening? Can I be in the story? Can I be at this high school, like looking and seeing what's happening? Also, I want to ask, like, how can I make any of this stuff real? Could it be that I just like sketch it out with a table or a picture? Is that how I make it real? Can I put my own numbers in? Is that how I make it real? Do I look at the answer choices? Is that how I make it real? First thing I want you guys to think about, right? Ignoring all else. Let's forget all the math and the what have you. A third of the seniors and a quarter of the juniors study Japanese. So does a large portion of the high school or a small portion of the high school study Japanese? A really small one. A really small one. A third of the seniors and a quarter of the juniors, which means 2/3 of the seniors and 3/4 of the juniors do not study Japanese. So most students in the school do not study Japanese. What answer choices do I get rid of if most students in the school do not study Japanese? A, B, and C. Yeah. Right? Like A, B, and C. So, because I want who do not, right? So the students who do study Japanese are actually a very small proportion. It's a third of this little bitty senior class and a quarter of this bigger junior class. But I for sure at least know it's not these three. For sure. For sure. And in fact, 7/12 is about a half. I'm not feeling great about that answer either, if I'm being really honest. 7/12 is not great, right? I'm not feeling that. And so I might just pick E because the only one that makes logical sense. And that's the beauty of some of this is like, oh yeah, the answer is going to be, I don't have to do any more math. We're good here. But what I could do is say, all right, they didn't give me any real numbers. Let me think about it. I know the junior class is twice the size of the senior class. Let me let the seniors be 12 because that's like a common denominator. And so the juniors would be twice that. So let's call them 24. And a third of the seniors, so that's 4, study Japanese. And of the juniors, a fourth of the juniors. Right, so what is that? 6? 6 study Japanese. And so then not Japanese in this group would be the remaining 8. Not Japanese in this group would be the remaining 3/4 or 18. And so not Japanese, that would be 26 out of, and then it was the fraction of the students in both classes. This would be 24 plus 12. So out of 36. Oh, I think there may have been a, oh, okay. Yeah, so if I picked 12 for seniors and just kind of like doubled that for juniors, and then just took the fractions of it. So a third of the seniors were studying Japanese, and a quarter of the juniors were studying Japanese. So 26 out of 36. Well, I'd reduce that by dividing both in half. So 13 out of 18, which I think is important, right? It's important that we be able to do this. I also think it's really important that they will make answer choices far enough apart that if you feel comfortable with fractions, that'll be enough. Which class is bigger, the junior class or the senior class? From the beginning, right? Junior class or the senior class? Junior class. Tiny fraction of the junior class. So in other words, the people who do study are 3/4 of the big class and 2/3 of the smaller class. We're going to have somewhere around like 3/4, 2/3 to 3/4 of our students are going to study Japanese. It'll be somewhere in this neighborhood. 7/12 is way too small. That's barely a half. That's barely a half. It's definitely not 2/3. 9/12 would be 2/3. And so out here we go. Yeah, 36, sorry, was the total number of students in my little story would be the 12 seniors and the 24 juniors. So 36 students. So the question asks which fraction of the students. So these are my not Japanese on the top over the total. So if you can make it real, you might even be able to get to the point where you're not even doing some of this math, because you're actually better at this than you think you are. A lot better at this than you think you are. You want to try one more challenge before I let you go? Okay. All right, give this one a try. All right. So last but not least, answer choices look crazy. Numbers are really weird. But I could make this real. I mean, I could sort of think about this. Like, all right, let's imagine my first yoga studio. Okay, this one. And let's say it's always at capacity and everything says percent. So let's say 100 people. I'm just kind of drawing it for myself. And I'm going to move to a new location that's bigger and it can serve 45% more students. So this one's going to be able to serve 145. But unfortunately, 20% of the current students are not going to be able to go to my new location. So I got to take 20% of my 100 would be these 20, which means these 80 people are going to go to my new spot. So these 80 people go to my new spot. If the classes at the new location are also filled, all right, well then how many do I need to show up at my new big yoga studio in order to be able to fill this place up? I got my 80 that came with me from the first studio. Well, that would leave me another 65 needed to fill my new studio. These would be 65 new students. And it says what fraction of the students at the new location, so what fraction of the 145 are new, that's going to be 65 divided by 145. So I'll, grab my trusty calculator, and because I don't know what 145 is divided by 5, but 65 divided by 5 is 13. 145, and I can stop because the answer's got to be D, but 145 divided by 5 is going to be, there it is, 29. I can also look at my picture and say a little less than half. A little less than half. Because 80 from my original studio, I just didn't draw very nicely to scale, but 80 from my original studio, and it's only 65 new ones, I need fewer than half of my students are going to be new students. So any answers that are more than half, it's too much. Too much. And it's not even really like close to half. This is still more than half. This is the first one that's just a bit under half. Pictures, numbers, they plug in, get stuff organized and sort of like tally sheets. Yeah, for sure, Joe. I appreciate it. Yeah, I love drawing pictures because you know what the very best way to visualize something is? With your eyeballs. Right? And not like, I wonder what that looks like. Put it on your paper. The beauty is that they give you paper or a whiteboard if you're taking it online. Make it real. All right. Well, it has been a pleasure getting to work with you, friends. Enjoyed this time. Happy New Year is like, really, I'm just happy New Year. We all made it. We made it through 2020. Who knows what 2021 is going to be like, but the memes, there's always the memes. The memes keep us going. The memes keep us going. Absolutely. I put a link in the chat window. I will throw it in the chat window again. This is the link to our free prep hour series of videos. At this point in the game, I think we've got 60 some of them of all sorts of topics. And be on the lookout. We're looking at trying to organize those into some fun, shorter playlists. So keep your eyes peeled. If you have not done so, by all means, we also have access to free practice exams. So please, by all means, go on our site, sign up for a pre-practice exam. And now that we're here in the new year, we also offer any of the first sessions of a class. You can come attend for free, hang out, learn some cool stuff. Right, so you just follow that link and you can find them. And then, as always, you can always come see us for anything. We got one or two of these that we do a month. We've got also, again, like attending first classes for free. You can try out our Interact for free. So lots of ways that you can engage with us while you're trying to figure out how you want to study and who you want to study with. But it was a pleasure. And again, my name is Whitney. Have a very happy new year. Very, very, very happiest new year.